Okay, I'm now officially recording this session. So uh, I just essentially started by explaining what Buster was, and you can see here where we did request a Buster on Hugging Face, and we got an answer with all the different sources. So I was kind of quickly explaining how it worked, and yeah. So now I'm just going to explain in detail how Buster actually works uh, through this live stream. So first of all, I'm going to start with a high level overview of how this thing works. And I would say there are pretty much like three steps to make this work. First of all, can everyone read? Is this good enough? The font size? I hope so. So there's three steps to make it work. Awesome. The first step is that we want to collect the source of documentation, parse it into some kind of readable format, and then embed it using a large language model. Now, I'm going to explain this in a bit more detail, but for now, I'm just going to go into the main steps. So the source of documentation that we went for was Hugging Face transformers. The reason why we decided to use the Hugging Face transformers was for a few reasons. First of all, it's a really popular library, so we had a feeling that a lot of people could benefit from it, but also their documentation is really good. It's just really well written, it's really clear. And so if you're giving it to a completion engine and you've prompted with a lot of this clear documentation, there's a good chance it'll be able to find relevant bits in the documentation. So the second part that we want is that we want to build a document retrieval system. So we take the Hugging Face documentation, we scrape it, we parse it, we embed it using a large language model, and then we get a user's question. We also embed it using the same model, and we compare it to these embeddings. By doing this comparison, we can get a score. So the score that we'll be talking about is the cosine similarity. Again, I'm going to go through these details a bit later, and that allows us to retrieve the top documents that we're interested in. Using those top documents, we can then craft a prompt where we take essentially the raw text, we append it to some kind of engineered prompt for GPT, and we add the user question. So we take all the documentation, we explain to the chatbot what it's supposed to do. So we say, you're a chatbot, you're supposed to answer questions. Now answer the following question, and we add the user's question. So in practice, this prompt is actually a lot more quote unquote sophisticated. So I'll also show you some of the hacks that we had to put into this prompt to make it a bit more robust and a bit better. But that's the high level overview of how this whole thing works. And then, it's all wrapped neatly into a Python API, and we'll go through it afterwards, how you could use it as well on your own projects. Okay, so let's do a little bit of a background here for those of you who don't have that much background in natural language processing. I'm not going to go super into the details. There's many really good tutorials out there that explain what word embeddings are, but it's just to give you a bit of an intuition. So most of these modern large language models, GPT, all of that, they all work on embeddings. So someone's asking to show point 2 again. Yeah, sure. So just really quickly, point 1, I'll do a quick summary. Point 1, we have the scraping of the documents. Point 2, we have the comparison of the question to the embeddings, and we retrieve the top documents based on that. And I'm going to go through all of these points in much more detail later on, but this is the second point. And then the third point is once we have these retrieved documents, we formulate the prompt. Okay, so now the word embeddings. So most of these large language models, GPT included, essentially most of the transformers, and I would say almost all modern transformers these days operate on embeddings. They're not necessarily word embeddings per se. They could be token based. Usually they are token based, but the idea is kind of the same. You take a word and you have to embed it into some kind of vector representation. So, a vector is just a continuous space, and it'll be a 1 by n dimension. And so the machine kind of learns automatically how to organize all of these different words and concepts into vector space. Okay, so we're not going to go into the details of how this actually works under the hood, but this is where you have things like mass language modeling, next word prediction, all of these different tasks that were come up with over the years. And there's a really good summary here that I would recommend you to go read if you're interested in how we can actually turn words into vectors and put them into vector space. Now, what's really useful is that once these words are in vector space, we can actually measure different things between them. So how far are they from one another? How similar are they to one another? And that's what we're going to be using in this tutorial. But for now, let's focus a bit more on the actual embeddings. So here I have a little bit of code that just shows you how it is that we can actually play with some embeddings. And for now, we're not actually using the OpenAI API, just because the OpenAI API, as much as it's great, you have to pay for it every time you use it. So I'm going to be sharing this notebook after the stream, but I want most people to be able to run most of these cells, even though they're not paying for OpenAI. So I'll be using a lot of open source tools throughout this live stream. But then at the end, like if you do want to use Buster, then you will have to have your own OpenAI key. Okay, so here we're using the sentence transformers library. And the reason I'm using this is honestly because their API is just really, really simple. So let's just load this up. I already installed it, but if you haven't installed it, just use pip install sentence transformers. And so they have a bunch of different things here. More importantly, we're going to load one of these models. So it's some kind of transformer. Honestly, I'm not even sure which one this is, but it's called a mini language model L6v2. You could go check out the documentation for what it is exactly. And so we're going to pretend here that we have a document right here. Okay, so this is welcome to this tutorial by Jerpint. So Jerpint, that's me. That's my handle on GitHub and on Twitter and everything. So what we can do with this sentence is we can actually use the model to encode it to a tensor. Okay, so a tensor essentially in this case is going to be just a vector. So this is what I'm doing here. I'm printing the shape and I'm printing the actual embedding. So let's start first by printing the shape. And you can see that it's a tensor of size of shape 384. So what that means is it's a vector that's 1 by 384. And if we actually print the content of this embedding, now you'll see it. Okay, you could see the contents of this embedding. And to most normal humans, this means absolutely nothing at all. But to the model, it kind of says, this is where you should place this sentence in vector space based on every other sentence that you've ever seen. This is where it makes sense to categorize it in this vector space. So now we have a vector representation, and you can see it's relatively sizable. Like we have 384, and so look at the values themselves, okay? Like minus this, whatever this value might be, minus 2.9, 10 to the negative 2. You know, if I change this and I put like, welcome to this cooking tutorial, this will probably be a very different value. You can see the value is just changed just because of what I put in the text. So based on the text and the semantic of the text, these models just learn how to place these things in vector space. And we're going to use what the model has learned to our advantage. Okay, so that's essentially the high level overview of what an embedding is. And so then when we collect the data, what we do is that we go and we take all of the documentation, and every little bit of documentation that we can find, we create an embedding just like this one. Okay, so I'm going to show you here, like we're going to come back later on as to how we use those embeddings, but for now I'm going to show you what it looks like to actually collect this data. So the first thing that we need to do is collect all the documents and embed them. So we're going to use the Hugging Face Transformers documentation. So here's the link to the Hugging Face Transformers. And you can see like all of these different things, you know, natural language processing, computer vision. And a reason why I really like this documentation for the project, like I said, is a lot of it is in plain English, which GPT is really good at understanding plain English in like really simple terms. You know, it's like probably one of the harder ones would probably be the Python documentation. Like for those of you who have ever read the Python documentation, it's very terse. It can sometimes be hard to make sense of. With this, it's just very clear, emojis everywhere, really meant to be like a friendly kind of source of documentation. So what we do next is we essentially shove it all into a pandas data frame. So for those of you who aren't familiar with pandas, it's a really neat library to have essentially like CSVs that you can order. So I guess I should mention first, the documentation for Hugging Face and most of their code lives online. It's an open source library. So for example, if you go to the Hugging Face Transformers GitHub, you can see here I'm under their documentation, source, English, and we have here a page on Bertology. Okay, so Bertology, I think this is probably a term that Hugging Face came up with. I don't know if it's like a real academic term, but it's a growing field of study concerned with investigating, you know, large-scale transformers like BERT. So anyway, they explain what Bertology is, but this is just a markdown file. You can see here MDX, so it's some kind of markdown format. So if we click on raw on GitHub, we'll actually see the source code, right, for this thing, and it's just your standard markdown. So what you could do is you could just come take this text, copy it, then we come here, and so here I already pasted it, but you can see I just literally just copy pasted this into this text block. So now we have a string representing this documentation. We also want to have a name here, which represents the name of the section. So the name of the section is Bertology, and the URL associated to this thing. So you can see the URL here. It could be related to the version, but you could also try to point it directly to main. And then the idea is that you want to build a data frame where we just have the name, the URL, and the text. And you would do this over and over for each and every single page. But let's just do this right now for this one. Okay, so that run. So now if I just run documents df, you should see we have only one entry with the name of the section, the URL, and like you could see the plain text here. So if I did document df.text, let's just print the whole thing. You can see this is really just the raw plain text of what we found here. So it's less readable for us, but it's much easier to handle for a machine. So now the idea is that you would do this for the entirety of the documentation. So you could, in theory, just do exactly what I did here and do this one by one. However, you will find that the documentation is very long for Hugging Face, and for most projects, it's really long. So what we did in this repo is we essentially implemented a bunch of scrapers. So we support two kinds of scrapers at this point. We support the Hugging Face documentation, which was a bit custom, and we have some scrapers for any kind of documentation that is in the read the docs format. So that is documentation that is built using Sphinx. We don't have that much information yet as to how to actually use these scripts, but we're going to add them soon into the repo. But it should be relatively straightforward to follow along. Okay, so yeah, so essentially we could have done these one at a time, but that's time consuming. So we have scrapers that will do this automatically for us. So once we have all of this, the idea is that for each one of our documents, we can then compute an embedding. And so here I just use the exact same model that we had earlier from sentence piece, but in the actual project, we'll call OpenAI right here. So instead of calling the sentence piece model, we'll call OpenAI's one of OpenAI's GPT models. So they recommend on their website the ADA-002 for using sentence embeddings. So that's what we use. And so we just call that essentially on the entire data frame. So we can create a new embedding column. And here we just apply the model.encode. So exactly the same function call we had before on our string. This is just a fancy way of using pandas on an entire column. Okay, so if we run this, now you can actually see in here, if I just link it, you can see that the embedding is now stored in this embedding column. Okay, so we essentially do this, and now once you've scraped the entire documentation, for each section, you also have an associated embedding. So I'm not going to go and scrape the whole documentation right now live for a few reasons. First of all, there's a bunch of steps involved. You need to clone it locally. You need to actually build the documentation into HTML because we actually use Beautiful Soup to do the parsing. So it's not enough to just point to the raw markdown files. Another reason why it's not enough to just point, like you could technically just go point to the raw markdown files hosted on GitHub, but because of how they build their documentation, they put a lot of references that only get built when you actually build the documentation locally. So we did a whole script with Beautiful Soup to be able to do this parsing. It's all in Buster, and there's more info right here. So I have the link here. You'll be able to go see it. But we have like parser scripts, and this is Adrien who did most of the parsing. So that was like he was really good at doing this parsing really quickly. And the Hugging Face one in particular was a bit harder because it's not using Sphinx. They have their own document builder, and it shows because their documentation is really nice. So the nice thing is though that we are hosting this thing, like the full documentation script for Hugging Face is actually being hosted on our space. So you could just download it if you wanted to. So right here you could see like you could just call this wget. You'll have access to this tar.gz file, which is just a format that we used to pickle the file, because if we saved it as a plain CSV, it was huge. Like it was really, really huge because the embeddings were kind of big. So here you can just run this cell. It'll download the file, and then I'll just remove this so we don't pollute our output. And then I just print the head of it so that you could see that we've done this before. We have an extra column here that we add in our code. It's not something that's necessary, but it's nice to keep track of, which is how many tokens does this text actually represent when you call the OpenAI API. So this is useful because you have a maximum tokens that you can actually send to OpenAI, which is 4,000, but that includes everything in your prompt. So you do want to be able to monitor how many tokens you're parsing, because if you were to just dump the whole thing into one giant block of text, this would not pass. Like, you would get an error from OpenAI saying you have way too much tokens in your request. So you can see here, this is just the first few lines of the file. So the different name of the pages, so community resources, community notebooks, all the URLs associated, the plain text associated, as well as the embeddings associated. And these embeddings were calculated using OpenAI. So yeah, that's the first big step. Okay, so now that we have all of this done, we take this let's take this step as already accomplished. The next thing that we want to do is document retrieval. So this is the step 2 kind of thing. So how do we measure the similarity between two documents? So now we have all of the documents available. We have all of their embeddings pre-computed. And now a user asks a question. So what we want to do is we want to figure out, given a user's question, so let's suppose that the user's question is embedded as this D1 embedding, and giving all the other sources of documentation. So let's just take one source right here, D2. What's the distance between them? And a really popular and easy way to compute the distance between two embeddings is to use something called cosine similarity, where you essentially just compute the angle between these two vectors. So I'm linking here. There's lots of really good pages on what cosine similarity is. It's something that you would typically see in like a linear algebra course. And it's really just a measure that says, are two vectors close together in vector space, or are two vectors far away? The value usually oscillates between 1 and -1. 1 means they're very aligned, or usually 1 means they point in the exact same direction, and -1 means that they're like almost opposite vectors. Okay, so once we have these embeddings, the idea then is that we can take a user's question, we can embed it in the exact same way that we embedded all of the documents, and we can compare them one by one. So for the question, for each embedding, we take the question and we measure a cosine similarity, and then we sort them by order of importance, which was the highest to the lowest, and we retrieve however many that we want to retrieve. So in our code, this is something that you can actually play with. For this demo, we used 3 documents that you actually retrieve. So this is a setting that you could put in the configuration of Buster, and you ask it for the top 3 embeddings that match best your query. So now I'm going to show you what this looks like in practice, these similarity scores. So here we're just going to be using the similarity score from the sentence transformers library. And so you can see here, I just have a quick function that's going to be looking at these things. So given 2 documents, and here I should probably put that these are 2 strings. Someone's asking, am I going to post this tutorial? Yeah, I'm going to post this tutorial, and we'll share it probably on the Discord. And I'll also post the whole stream will be posted on YouTube as well. So all of this is being recorded, and the notebook will be posted. You'll have access to all of this documentation. Okay, so here we have a function, and the goal of this function is just to print the similarity between 2 different vectors. Okay, so give it, 2 different input strings. So given 2 strings, print the similarity between these 2. The way that it works is, first we print the documents themselves in plain text. We embed each one of these. So we use, again, our same language model to embed them. And then we just compute the cosine similarity using one of the utility functions. And we just print that out after that. So here I have a bunch of different documents, and I want to show you just like what it means to actually compute this cosine similarity. Okay, so here I have 4 types of different documents. So the first one is dogs are a furry type of animal. Then I have cats are also very cute and fuzzy. The current economic situation is dire, and I was never really good at saving money. All right, so you can already have a bit of an intuition as to what should be more related to what. So let's start printing these things out. So here we do the similarity between the 0th document, so this one, and the first document, so this one. Or maybe I'll just put this here so we have a better idea. So now we're comparing this one to this one. And we get a similarity score of 0.5 with this specific model. Okay, so 0.5, remember I said the range was between 1 and -1. So that's like a kind of crude way of measuring this. Let's say a bit like a 75% kind of similarity. It's not exactly how it works, but 0.5 can be considered high on this scale. Now, what if we compared this first sentence to, actually, before even comparing this first sentence to the last sentence, let's just change here. Cats are also, and put dogs are also very cute and fuzzy. Now this should be a lot more similar. So remember we had 0.5, and now let's do that again. And you can see if we went from dogs back to dogs, this scores even more similarly, okay? And another thing that's really interesting, right? The maximum that they could score in theory is if it's the exact same vector. So here, let's just compare the two first sentences together. And if I compare dogs are a furry type of animal to dogs are a furry type of animal, we get what we'd expect, which is a similarity score of exactly 1. So now let's try to compare the first sentence to the last sentence. Okay, so here let's put the last sentence. So now we're comparing dogs are a furry type of animal to I was never really good at saving money. And these two sentences, as you would expect, aren't really related at all. So now we're starting to score into the negatives. But what if I compared like something about the economy and something about me saving money? So here I could put like the second document, and here let's just make it more explicit, put that as the last document as well. And you can see here, current economic situation is dire. I was never really good at saving money. And well, that's already a bit more related, not super related, but kind of more related than it was to the thing about the dog and the cat. So you could play around with all of these things, get a good understanding of how these things work. Someone's asking if he's the only one having audio troubles. Can everyone else hear me well? I'm hoping he's the only one. Can hear well. Great. All right. So I'll continue. Loud and clear. All good. All right. So let's continue. By the way, I really want to insist, like, if you guys have questions related to any of this or like what this means, if you're lost, like, please ask questions. It's always better to, have a dialogue with internet people than to just like talk to myself about all of this. So yeah, please don't hesitate. If some of this stuff is not clear, if you want some clarifications, just let me know, and I'm more than happy to answer your questions. Okay, so someone's asking the requirements. We'll go through the requirements a bit later, but there's not many requirements. It's basically just OpenAI, Pandas, and a few other libraries. But we will go through the requirements at home for people who want to try this at home later, what the requirements actually are. And so if you're using the OpenAI stuff, the really nice thing as well is you don't need to have a GPU, because you'll use OpenAI's GPUs. So yeah, let's continue. So now going back to what we want to do with Buster, it looks something a little bit more like what we have in this cell. So you'll have a question that comes from your user. Okay, so the user might ask you, what is the best model to deploy on text? So this could be a very legitimate question that you would ask Buster. And now you have a series of documents that you scraped from the Hugging Face library. So you might have one document that contains the sentence, BERT is a large language model trained on text. Vision transformers work really well on images, and multi-layer perceptrons are a type of neural network. Okay, so if we compare this question to every single document, which one would you expect to score the highest? So there's already a few hints here, right? By just looking at the words that they contain, we got text and text in these two documents, so we would expect that to already score a little bit higher. But even in the context of these things, right? Best model to deploy on text, and BERT is a text model. Like, there is high similarity between these things. So let's just run this, and we're essentially just looping through all the documents and comparing the question to each document. And so you can see for the first two sentences, we get a relatively high similarity score compared to all the other ones. And then how important these similarity scores are will really depend on the quality of your models. So like with the OpenAI embeddings models, we tend to see like similarity scores of 0.9 when concepts are very related, and then maybe closer to like 0.6, 0.7 when they were less related. So it really depends on how these models were trained. Not all models will output similar cosine similarities for similar sentences. This is really just an artifact of how they were trained, right? Based on whatever it is that they optimize, whatever their final weights end up being is what's going to determine these similarity scores and how good they are at these things. And also, another thing I should point out is a lot of these models weren't trained to necessarily score high on embeddings in feature space. They were just trained to predict the next word. So it's kind of an interesting application of these models that we can also use these embeddings, but it's not directly optimized to do that. So keep in mind that when you're embedding these things, it was never really meant for this. It's just a nice artifact. Maybe in BERT, you could say that it was kind of done by design when they were fine tuning on these different tasks with the CLS tokens, like because those CLS tokens would actually collect all of those embeddings and try to do essentially a regression on those values. But when those models are trained, they're really just always trained to predict the missing word or predict the next word. Someone's asking, could this work with Flan T5? Yeah, actually it can, and we're going to use Flan T5 just in the next example as well. So definitely you could use this with Flan T5. This is very agnostic to the kind of model that you want to use. And then Flan T5 comes in all sorts of different sizes as well. So we'll actually go to the next section where we're talking about Flan T5. So we went through the first two parts. And now the next big part that we have is to actually generate answers. So how do we generate answers? This is where like all these models like GPT come in. These are generative models, and they allow us to complete essentially text. So we're using OpenAI's GPT 3.5 completion model. So that's the text DaVinci 002 model that's currently available on the API. So this is what we use for Buster. But in this example, I'll actually be using the Flan T5 model for generating some responses. Again, just because it's open source. So when I'll be sharing this notebook, you guys can actually run this without needing to provide OpenAI with an API key. So that'll be something that you can just play around with. So the T5 model that we're using here, we're taking it directly from the Hugging Face Transformers library. And so you can see we're using Google's Flan T5 small model. So this is like the name suggests, this is a very small version of T5. I believe T5 goes up to XXL. Obviously, the bigger it gets, the more weight you have to load, the more time it takes to run, the more beefy your computer or your GPU needs to be to actually have this thing run in real time. So we just load the Flan model here. We also load its tokenizer. Anyway, this is more like Hugging Face related stuff. But the idea being that we can, given an input to our model, we can then generate the rest of it. Okay, so the input here, what we're going to do is we're going to ask. So we're going to say we're going to prompt our model with BERT is the best. This is a typo. BERT is the best model to deploy on text. And then the question of the user is going to be, what is the best model to deploy on text? So we're going to combine these two things, so the document plus the question, into one string. Okay, this is essentially going to be the input that we're going to give to Flan, and we're going to ask Flan to complete the sentence. So we're literally going to prompt Flan with, BERT is the best model to deploy on text. What is the best model to deploy on text? Now, this is a really easy thing to answer in theory, but this is also Flan T5 small, so you're going to see it's going to be okay at answering this question. So let's run this cell. You could see it thinks a little bit. So it's loading everything. It's loading the tokenizers. And now you can see that it responds BERT. Okay, so it's really just spitting out, like, kind of by design, BERT is the best model to deploy on text. So now let's play around with these things. Instead of putting BERT is the best model to deploy on text, you know what? Let's put GPT is the best model to deploy on text. What is the best model? And you can see it. Like, it's a really not as good as GPT to generate like long coherent sentences. But if you were to take Flan XXL, I'm sure you would get much better results. Okay, so keep that in mind. This is one of the smaller models that we can get, and they provide them in different sizes. And if we said there is no good model to deploy on text, and we send this to T5 to document, we would say, what is the best model to deploy on text? And now it just says no. Like, there's, it's ideally it would have said there is no best model to deploy on text, but you can see that it has already a bit of an understanding. It shouldn't exist. So this is kind of how we do, what we do with Buster to prompt it. We actually pass in all the documents as context and then ask it to formulate the rest. So this is what we call prompt engineering. And I would argue that this is a big part of what makes Buster so powerful and useful. And it was surprising, honestly, at first how well Buster was answering. But I think that the prompt engineering was one of those things where the more we played around with it, the better results we started getting. Now, if you're not familiar with prompt engineering in general, there's a really good resource here that I really recommend you go check out. This website called learnprompting.org. Shout out to Sander. I think he might be in here. He's the brains behind this whole thing. You could really learn everything about prompting, and this could be prompting for any kind of generative models. But the idea behind prompt engineering is really like you have to, in plain English, give instructions to kind of hack GPT to give you responses in the way that you want. So in the earlier image that I showed you this thing here. We have the retrieve documents, you have some kind of prompt, and then you add the user's question. But now I'm going to show you like the actual prompt that we used for the Hugging Face library. So you can see it's a much more intricate prompt. So the prompt is this thing right here. Okay, so the first thing that we do is we give like imperative directions to Buster. We tell him, you are a chatbot assistant. Oh, here, technically it's not Slack. We did deploy this thing on Slack as well, but this one is a Hugging Face space, but whatever. It doesn't really matter. It works just as well. So you say, you are a chatbot assistant answering technical questions about Hugging Face transformers, a library to train transformers in Python. Make sure to format your answers in Markdown format. So this is one thing that's really neat also. For those of you who've played around enough with Buster, you probably noticed like it gives you code snippets and they're properly formatted. It gives you links and they're usually properly formatted. This is all GPT is doing natively because we're telling it, make sure to format your answers in Markdown format. And GPT really understands pretty well what Markdown is because Markdown is really popular format online. So we say including code blocks and snippets. So we want to make sure that it formats them properly. And this is another important one. GPT tends to hallucinate a lot. This is a really known kind of behavior of GPT, ChatGPT as well. It's not ideal, but it'll very gladly make up links and URLs that kind of look real but don't exist. So this was another instruction that we had to add because we're already citing the sources because we know which documents we retrieved from, so we can cite the sources. But we saw that in some of our responses at first when we were playing around with it, that on top of that, GPT was providing its own made-up sources and links, which is really not a good thing. You really want to have this kind of be sources that are real, that exist. So this was another prompt that we included here. We said, do not include any links or URLs in your answers. So another thing that was also a kind of prompt engineering hack was GPTs and GPT models in general are very happy to make up an answer that they have no idea about or that's completely unrelated to the task at hand. So this was another bit of prompting that we used, prompt engineering technique, where we say, if you don't know the answer to a question, or if it's completely relevant to the library usage, simply reply with, this doesn't seem to be related to the Hugging Face library. And in fact, for those of you who've played around with Buster, maybe we can go try it out now and just see like how well this actually works. So here, let's say, what's a good recipe for, I don't know, who wants to know a good recipe for what? For pizza, let's say, for pizza and, I don't know, let's just say pizza and pasta. Okay, so now the processing time is much slower because I think less people are using it. Oh, so now actually it didn't really work that well, but usually it, this is a failure case, but sometimes maybe let's try to ask it like, what's the closest planet to our sun? Well, hopefully we'll get something that works. No, I don't know why it's answering. I have to check out what's happening. The hot moonlights in pasta. Yeah, I guess so. Usually it's supposed to not answer this, so there might be something wrong right now, and I'll have to go check this out. But I have seen it many times before not answer these irrelevant questions. So obviously when you're showing things live, things tend to not work. But let's try something completely irrelevant. What is larger, an elephant or a mouse? No, okay, there's maybe a bug that I have to go figure out, but this could be like because of a new deployment that we did recently. So I'll have to check this out. But in theory, and I telling you this worked in the past, right? It was really good at saying this doesn't seem to be related to the Hugging Face library. So I'm gonna go check this out after the stream and try to investigate a bit further. But in theory, if this bot works well, the way that we had it, it was generally pretty good at saying, I don't know what you're talking about. Yeah, so going back to the prompt engineering, another thing that's really important is that we add the retrieved documents as, yeah, Murphy's Law, exactly. Only during a live stream do things not work. Yeah. So here for the prompt engineering, another thing, so on top of this really like well-crafted prompt, we also put in plain text all of the retrieved documents. So really this is just like, for now, it's kind of just raw plain text that we copy and paste right before, and we just append it to the prompt before. So that Buster has context as to what it is that we're actually asking it about. Because GPT 3.5, like the Text DaVinci 002, it stopped being trained in 2021, I think, and right now we have like maybe 1 or 2 more years of documentation of transformers of models that it would not be aware of. So by adding these documents right up here, we actually give it the context that it needs, and it can actually answer about more modern models as long as they're in the Hugging Face library. So this is kind of a way to get around the fact that GPT's knowledge stops at 2021. We actually give it all the most recent knowledge that it needs to answer these questions from the retrieved documents. And so another little neat bit of this, right? Because we know which documents were retrieved, we can simply add these. So we have a section in the code where we just add all of the URLs afterwards with the relevance scores. So people can have a good idea of what these relevance scores are. Okay, so now putting it all together. So we have all the little bits and pieces now, but how do we actually make this thing work? So we need to put this all in a nice clean API. So when I first started hacking this thing together, we had a whole bunch of different functions, all the different pieces. And at some point, the code starts spaghettifying out of control, and you want to start cleaning up and doing some house cleaning and making sure that this goes into an API that's nice and easy to use. So this is actually, in my opinion, a really good use case for ChatGPT. And I actually use this, okay? So I asked ChatGPT, I said, I'm building a chatbot in Python. I want to build a clean class interface for my project. The bot has to first compare a question to a series of documents, pick out the best matching documents, then generate a response based on the retrieved documents. It must also format the output once generated. Give me some skeleton code where I can fill out the actual functions so that my interface is clean and easy to maintain. And ChatGPT gave me this really nice looking skeleton. And it was kind of cool too, because essentially a lot of these separate functions I had as just all over the place different functions, but they were already kind of atomic functions. But now I had a good idea as to how I could put this so that it just looked clean. And I did not ask it to write any code for me. It does write code pretty well for simple functions, but for this kind of stuff, I really didn't want to have it write code for me. But I did want to be inspired with like, what's a nice interface that could like someone could just read and it would make sense to them. So I actually used this for the code to inspire myself. And this is what the actual code ended up looking like. So you can see it's a bit more involved than what GPT gave me, but it was a really good like first step. So we have a rank documents function, a prepare prompt function, generate response, add sources, format response, and finally like the process input. That's kind of the main of this chatbot. But I have to say this was pretty useful because at some point you start looking at your code a bit too much. You always have this fear that you're going to over engineer it too. So having something that's just like seen, hundreds of millions of lines of code, giving you a suggested skeleton was really useful, and so I used that for us. So now, how do we actually use Buster itself? So yeah, this is all the bits and pieces together, and then the actual code itself. We can go through some of the code if you're interested, but I'll show you more how to interact with our API because we wrapped it up essentially in a pip installable package that you can just import and use directly yourselves. So first things first, to be able to use Buster, and so for the rest of this tutorial, so all of this before you didn't need a valid open API key, but for everything else down here, you do need a valid open API key. So first things first, you want to pip install the package. It's not yet available on PyPy. Maybe we'll put it up on PyPy at some point. But for now, you can just simply install it by using this bang command in your notebooks. So or just locally you can pip install it. You can also install the package from source. Right now it's still in beta, the kind of development mode. So if you do this, then you'll actually be able to edit the source code and mess around with it, debug it, maybe adapt it to your needs. So up to you how you decide to install it, but it is relatively easy to install. And someone did ask what the requirements were for Buster, so we can go look at the Buster requirements. So here we have a list of requirements. So these are most of the requirements that we use for the thing. So Beautiful Soup is for the scraping, NumPy and Panda is just like some basic stuff. And then almost every other dependency is OpenAI that required us to have it. So you can pip install OpenAI embeddings. That would have been a lot easier, but there's something that breaks our CI when we do that. So we just here have the list of requirements that they have to use their library. Some of them are really not necessary for this project, like Matplotlib and Plotly. We're not doing any kind of plotting, but if you want to use the OpenAI embeddings dependency, they call those imports, so your code will break if you don't have these. Anyway, if you just pip install our requirements file or just pip install the project, it should take care of installing everything that you need. Okay, so going back to this thing. So assume you've done all this, set your OpenAI key. Okay, I have an OpenAI key set as my environment variable. So this is kind of the typical OpenAI API stuff. So just here checking that I haven't a set API key. If you don't, this is just going to default to none, and this is going to raise you an assertion error. So you just won't be able to use the rest of it. So what you can do here is you download the weights. So this is something that you would do yourselves if you wanted to do this for a separate source of documentation. Make your own sets of embeddings, right? Like go scrape the documentation you're interested in, go make your own sets of embeddings, and then shove it all into a data frame. So here we provide them already. They're hosted on the Hugging Face space. So whatever, it downloads it all. And now here I'm going to show you how we used Gradio. So Gradio is what we use to deploy the Hugging Face space. And this is essentially what our Gradio app looks like. So here's the entire configuration we use for the chatbot. So we have a chatbot configuration. So this was part of the whole refactoring thing. So you have to specify a bunch of different things. First thing that you want to specify is the file in which your documents live. So this can either be like a tar file, a CSV file, as long as Pandas can read it either through from like read CSV or read pickle, this will be supported. The unknown prompt. So this is something that I didn't really talk about, but maybe later we can talk about it. It compares the response that is given by GPT to this unknown prompt, and if it scores high enough, then the bot says I don't know. So I suspect that because it wasn't working before, either this prompt on the app is not well configured, or maybe we're being a bit too strict with the cosine similarity between the unknown prompt and the response. So I'll have to go check that out offline once we figure that out. But it definitely, take my word for it, I guess, but it definitely works. It's just today is not working for some reason, so I'll have to go explore that. Here you specify the embedding model that we want to use. So this is the OpenAI embedding model, and this is the text embedding ADA 002. So you can go read the documentation. And then a bunch of different settings that you can play around with. So the number of maximum documents that you're going to retrieve, it's set to 3. We find that 3 is usually a good enough default, but you can play around with it. Then here is a threshold. So the minimum cosine similarity score for a document to actually be thought of as a source. If it's below this number, then just ignore those documents completely. This is something that we also have. So the max number of characters that the retrieved documents can span. So if we have 3 documents, each of them have however number of characters, there is a limit to how much you can send to OpenAI. It's usually measured by tokens. This was kind of a rough guesstimate. We want to limit maximum our entire prompt to 4,000 tokens. So 4,000 tokens can be roughly thought of as about 4,000 characters. It's not exactly, but roughly. So we take about 75% of that for the documents. Otherwise, they just get truncated. And then we append the prompt and the text before the prompt and all that. Yeah, said by all programmers every day. Yeah, I know. What do you want? It can't always work, but at least the space is up and running. Like that would have been even funnier, right? During the live stream, like I ping the space and that doesn't even work, or it like starts giving me answers completely unrelated. So yeah, whatever, it is what it is. But we'll get it working, and I'll post an update at some point when it's working again. But and you know what? Actually, I have I have the logs of every single request that gets made, and I've seen it in the logs work. So maybe later I could go fish it out in the logs and be like, you see, I thought it used to work, but right now I don't know why for the live stream it decided not to work. Okay, so the next things that we pass here, these are just the parameters that we pass to GPT's engine. So for completion, so here we're telling it use the Text DaVinci, sorry, it's Text DaVinci 003 model. I think this is the latest one. So this is what they call GPT 3.5, and then the maximum number of tokens that it can actually output. So, you know, we want this to be complete, but not too complete, or, you know, at some point we want it to stop. So this is where we tell it to stop. This separator thing, this is kind of important. Depending on how it is that you're serving your app, the line breaks will render differently. In Gradio, for some unknown reason, the \n, it doesn't like it. It only likes this break thing. So it's like an HTML thing. So we need to use the break as a separator. But if you're deploying this as any kind of other bot, like on Slack or on Discord, anything that supports Markdown, then you could use here a \n instead. The link format, so this is just for the retrieved sources. This is the only thing that we format ourselves. You can have it format in Markdown, but also Slack has its own formatting for links when you're a bot. So when you're not a bot in Slack, everything is formatted in Markdown, but when you're a bot and you want to format a link, you need to have a special Slack format. So we also support that. And then we have the text, like a generic text that you want to put after your response. So it's usually good to remind your users that you're a bot and that you're not always perfect. You know, so here my answers aren't always perfect. I've seen it as well. Like if you ask questions that are a bit more technical or challenging or require a bit more chain of thought reasoning than otherwise would be necessary, like if the answer is not directly within the source of documentation, Buster can make stuff up. So it's really important to remember the users that the answers aren't always perfect and that Buster's a bot. And then we have the text before the prompt. So that's what we saw before, our prompt engineering. And then we instantiate our bot. And everything else here, this is Gradio stuff, okay? So this is just how you can use Gradio to deploy your web app. So you have a chat function. This is a little bit of a formatting hack for Gradio because otherwise it was breaking our Markdown. But otherwise, everything, all the formatting is taken care of by GPT. And here we just have the actual interface, what it looks like. So, you know, essentially how this looks on our interface right here, like this stuff, these examples, you know, all of this stuff, the links to GitHub, this is what we have over here. And what's really nice about Gradio is that you can actually test all of your stuff locally. So right now I'm going to run this cell. It should be running. So it's in debug mode. So you can see I have also all of the logs, access to all my logs right here. And now you can see that we have the exact same interface running directly within our notebook. So you can actually debug this thing without having to launch it to a Hugging Face space every single time, which is really nice because, you know, then you have to wait so long every time you deploy it. It builds all of these things. And so now you can start asking your questions. So let's try again. Let's try to see if this might work. So what is the meaning of life? Okay, hopefully this says, I don't know, but we saw today that for some reason it wasn't working. So let's find out. Well, all right, at least Buster is philosophical. Even though our token is not working today, it says the meaning of life is a personal question without a single answer. It's different for everyone. We each have our own unique life experiences and perspectives on what life holds and what purpose it serves. You know, that's actually really good. So thank you, Buster. And you know what? It's actually a good thing maybe that the unknown classification is broken because we got a really uplifting message for today. So at least there's that. Just to go back to it, why I'm pretty sure there's a bug is if you look at the prompt, you know, I really had it here. Like, what is the meaning of life for Hugging Face? And it's supposed to answer, this doesn't seem to be related. So there's probably a bug somewhere in my code when I did some refactoring that it's not triggering the actual response. But actually, maybe I'll have a better idea if I look at the logs. So you can see here all of the different logs. So this is also very helpful when you're debugging your app you can see everything that was taken, the cosine similarity for everything. So you can see that the cosine similarity, even at with these prompts that have nothing to do, we still score kind of 0.74. So that's something that you really, I have to play more with the GPT embeddings to kind of understand what this cosine similarity means. But so far, I don't think I've ever really seen something go much below 0.7. Like, so there's definitely some calibration there that needs to happen. So the one thing that so we could see here the prompt that we used. So this is where, what is all here? Yeah, so this is where, these are all the documents that it retrieved and that it added. And then we can see that we add also like, you're a chatbot assistant. If you don't know, simply answer these things. Okay, so this is interesting. This is what I think is broken right now, and I don't know why. And this might be something related to, I wonder if there was maybe an update on these models. Probably not. But usually what I would expect here to see is this unknown score to be much higher. I don't know why this unknown score right now is so low, because the way that this unknown score works is it takes the response. So this is the response that Buster gives me. The meaning of life is a personal question without a single answer, and it's supposed to compare it to this thing right here. In my configuration, this is the unknown prompt. This doesn't seem to be related to the Hugging Face library. I'm not sure how to answer. So I guess I don't know why it is that it's not saying this doesn't seem to be related to the Hugging Face library. And now we could probably investigate more with our prompt engineering. Like, this was working a few days ago, and today it's not. And this is also the kind of annoying thing of working with a closed sourced API, is we have no idea what changed or what didn't change. So I'm going to have to investigate this a bit further, but you can actually see clearly, like, we prompted it with, if it's not related to the Hugging Face library, just reply with this. So what is the meaning of life for Hugging Face? It's supposed to say right there. So let's just try this right now. What is the meaning of life for Hugging Face? And then we'll know if something is like really wrong in the code or if something went wrong elsewhere. Because now this is really like GPT is just not following instructions at that point. So let's see what it answers. Yeah, there's definitely something weird going on, because now it says the meaning of life for Hugging Face. So that should definitely score really high on the, well, not only that, but it should also, from the prompt engineering, like, GPT is not respecting what it is that we're telling it to do. So here we have, what is the meaning of life? And it doesn't seem, so why would it not do this? I don't know. I'm going to have to look into this, but that's kind of weird. And I really do wonder if it's possible that there was an update to the model that was done without us knowing, because seriously, like, nothing has changed to my knowledge in the last few days, and this has been working pretty well up until now. So yeah, I'll have to explain that. Yeah, AI is taking over already, exactly. Anyway, that is pretty much most of what it is I wanted to show. So yeah, and yeah, exactly. Useful, right? So I want to put the blame on myself. I want to say that this is probably something like some bug in the code, but because this is closed source, like, I have no idea. The only thing I can say is use this model, but if they decide to change the model, I'm not in control of that. So there is a chance that there's a bug that slipped in, but the API has not changed significantly in the last few days that we've deployed this thing. So I'm actually quite surprised to see this being pretty different. So I would say there is a possibility that this model has been updated and there's just nothing I can do about it. But it's also a possibility that this isn't working. But I would say, like, from my experience with prompt engineering, when you say, like, for example, here's a question, now answer something, this doesn't seem related, GPT is supposed to follow these instructions. So I'm very, very, very perplexed as to why this is not following the instructions. So yeah. Anyway, this kind of sums it all up. So I'm happy to answer a lot more questions if people have questions. If you have just some other things as well that you want me to cover. Otherwise, this pretty much covers most of what I had to show you today in terms of, like, code snippets and how to use this library. We're still kind of in a very early phase with Buster. So we're going to try to add more docs to like how to use this thing, be a bit more user friendly, show some more examples. But if people have other questions as well, please just ask them in the chat and I'll go through them. Otherwise, thank you all for being here today. I see there's a bunch of people typing, so maybe I'll just wait a bit and see if there are a bunch of questions coming up. Oh, that's a really good question. Okay, so there's some good questions coming. All right, let's try to go one by one. You are using Pandas data frames to store your embeddings. How would you do if you had a huge amount of documents and they would not fit in a data frame? Which database would be suitable? Yeah, that's a great question. Honestly, it's a question I don't want to have to think about right now. For now, CSV is the ultimate database that we're using. CSV is the best database out there for now. No, it's a really good point. I don't know. I'm not really a pro at setting up database backends and stuff like that. I'm sure there's lots of people with lots of good opinions on what you could use, but so far, I mean, the amount of embeddings that we have, it all fits in like a CSV file that's less than 100 megs, or let's say a pickled file that's less than 100 megs. So you can easily load that into memory, even on like most free tier services. So it just really minimizes the overhead of having it all in a data frame. But if it started getting out of control, I mean, there are definitely things that make Pandas data frames handle larger things, but also for sure, like if you were to deploy this as a real app, you would have users, you would want to keep track of prompts, everything else. So definitely some kind of relational database would be a good idea, but I don't have a good suggestion for it. Another thing that I would mention as well is if you have a huge amount of documents. Right now, we're just using the basic OpenAI cosine similarity function. They provide one with their API, but once you have to start searching for millions of documents through embeddings, there are some libraries that are actually meant to do that really fast. Like one of them is the FICE library. I think it's from Facebook Research. So this is probably something that would be in the next steps to do as well. Like do some really fast, efficient similarity search. I don't know how OpenAI does it under the hood, but I can't imagine it's something super efficient in their API. So definitely, if you want to scale this to millions of documents, think of using some kind of framework that does that. The next question is, what's the cost estimate for Ada or DaVinci that you've seen so far? So Ada is definitely much cheaper than DaVinci. I think it's like orders of magnitude cheaper. So it's much, much cheaper to do the embeddings than it is to do the completions. I was surprised at how cheap all of this was. So we built this whole thing in about, let's say, like the first prototype took about a day, but then the actual deployment of it all took about a week. And during that week, we were pinging the chatbot a lot. We did a whole bunch of different sources of documentation. We used the OpenAI API extensively. And by the end of like a full week of debugging, it cost me less than $3. So you could like think about what that means, right? If you were deploying a web app with a GPU, $3 per hour on Amazon, you'd get a pretty good GPU for 1 hour. And we had for $3 like all the debugging that we could possibly do. And we did a lot also of playing around with the bot, like testing its responses, seeing how it worked. So yeah, really cheap to run. The only downside I would say, which is a bit unfortunate, is you need to have a credit card and an API key even to just play around with it. It'd be nice if it was like a kind of free tier, you could get a few prompts just so like I could share this notebook and everyone could run it without having to pay. But there's no way to run anything for free at all. You need to absolutely have a credit card on your account to be able to run anything. So the plus is it's pretty cheap to do these things. The minus is that you need to have a credit card that's on the account. But they do have like, you can set the maximum amount allowed. So I think I had mine set to $20 for the month, and then they'll send you a warning once you get close to that. So it is well built in that you're not going to bust your limits without you knowing. It's not like AWS where you can have a server running and you forget about it. And like you wake up in a few days or a few weeks and there's a couple $100 with your name on it, and you're like, oh damn, what did I do? So that's nice. Then someone is asking, is the cosine similarity a good choice in such high dimensional state space? I don't know if it's the best choice, but it is a good choice. It's a good choice because it's easy to understand. It's a good choice because it runs relatively fast and efficiently. And it's a good choice because it seems to work empirically, but we didn't test other types of metrics and distances. And I'm sure that in this high dimensional space, like that's probably why we always have such a high cosine similarity, even between things that are unrelated. Like I think that the ADA embeddings are 1 by 1,000 something dimensions. So I remember seeing somewhere that when you're in very, very high dimensional space, even when things are very far apart, they're still very close together when it comes to cosine similarity. So yeah, probably cosine similarity is not the best, and I'm sure there's lots of literature on the best things that you can use, but it is the best thing to like quickly hack together. It's also supported by most frameworks, and it's what's recommended by the OpenAI embeddings API. So you could definitely have an edge if you were to do some research and find some better applications, but I think it's a pretty good one for getting started. I'm not sure what FICE uses under the hood. Maybe they use something else than cosine similarity to do your embeddings retrieval. So probably go check out their library and see how they're doing it, and then you can think about that a bit longer. When is live going to end, or how much long live going to continue? I'm not sure what that means. Oh, the live stream, I guess. The live stream, yeah, probably soon. I mean, we've been on here for an hour, and I don't have much more to talk about. So I'm just gonna finish answering everyone's questions, and then I'll probably sign off. And we'll be sharing all of these documents on the Discord. So join the What's AI Discord. This I think this is the what you're already on the What's AI Discord. So we'll post it in all the different channels. Louis will take care of blasting everyone with all the links. Um, OpenAI said about cost per question about like fractions of a penny. What expectation and model biz on paid search? I have no idea how to answer that honestly. Yeah, whatever OpenAI said the cost might be is like the best thing I could possibly come up with, but I'm not sure. Like to run your own A100, I don't even know what they go for right now on AWS. You could also get them on Hugging Face. I think they have some pretty good offers for A100s as well. But yeah. Now, next question is, can you host the chatbot locally? So yes and no. So you can host the entire chatbot itself locally, yeah. But every time someone uses the chatbot, it pings OpenAI. So the model itself, you cannot host because OpenAI does not release their models, right? OpenAI, like it's open API. There's no open models. It's open for everyone to use the API. It's not open for everyone to use the models. So yeah, you can host the chatbot itself locally, but every time someone pings your chatbot, you need to make the request to the OpenAI servers and hope that you get your answer on time. Can you use already scraped content from not just search engine? Yeah, you can use content from anything as long as you put it into the right format for the data frame. Like at the end of the day, you can even adapt this to your needs. It's really just plain text, embed them, and then you can use whatever you want for that. Not only a cost problem, a lot of companies don't want to rely on OpenAI API. Yeah, 100%. I completely agree. Honestly, that's the one thing that I'm like not loving about this Buster bot is we're completely reliant on the OpenAI API, and everything we send goes to their servers. So it's really nice and cute for the Hugging Face Transformers library, but if you try to go to a company and sell your services, like good luck with their private IP and data. You should have a chatbot like this. I mean, it would be really useful, but it should be completely sealed off to the outside world if you're going to be asking it sensitive questions about like internal documentation and internal IP. So 100%. We have hope coming, that like the people at Lion and all that with the open assistant. Like, I mean, I'm sure it's a matter of weeks until we have a pretty good chat GPT, or not chat GPT, but GPT in general replica. There already are models that are of the similar sizes, just maybe not as good. But like the Flan model is completely open sourced. You can host it. The Bloom Z model is completely open sourced and you can host it. It's just a bit, there's a lot more overhead into hosting these things. So like I mentioned a bit earlier that myself and Adrien, who built Buster, we had this up and running and like answering questions in about a day. But if we had to worry about hosting the models and running servers, that would have been impossible. And the fact that this cost us $3 to run for like a full week's worth of debugging, if we had to run this on servers that were hosting these models, that would have been an astronomical cost. So there are advantages to using the OpenAI API, but definitely if you're doing something more sensitive, hopefully in the next few weeks we'll see some open source models floating around, and we'll be able to build some stuff that's like completely non-reliant on OpenAI anymore. And also, next time I do a live stream and something fails, like I won't be able to scapegoat on someone else's model. Like right now, that's my best excuse is I don't know, maybe the models changed, maybe not. Probably it's a bug of mine, but then you'll be able to say with certainty, like I have the checksum of the model. The model definitely did not change. Therefore, there is a bug in my code. Right now, I have to keep that as an open possibility of the model might have changed and I have no idea. Someone is saying, what are the benefits of using AWS versus local hosting if both ping OpenAI? Well, if you're using local, you're not paying. AWS, you'll be paying. They do have a free tier, but free tier, I'm not even sure what the conditions are there, but you maybe get a limited amount of free tier per year. So there's not necessarily a good or bad. Like right now, everything is hosted on Hugging Face spaces, and I don't know what Hugging Face infrastructure they use for like hosting all this stuff. I doubt that they have their own GPUs. So realistically, on the Hugging Face space itself is probably being hosted somewhere on AWS, and so essentially this whole Buster thing is already hosted on AWS anyway. Can we ask ChatGPT for hosting the site? Means for programs and prompt engineering. Is Buster using OpenAI API? So Buster is using the OpenAI API, and no, you can't ask ChatGPT for hosting the site, but you can host it yourself. Very excited for some open source models. Appreciate the demonstration and conversation. Yeah, thank you. And I'm also very excited for the open source models, especially because like the open source models, you can fine tune. Right now, OpenAI has a kind of fine tuning API, but like I said, it's all closed source. Like I don't know. People like to hack these models. You could use the weights to do all sorts of different things, plug them into other things. When you're just given the embeddings, it only goes so far. All right. Well, I think that's probably most of the questions. So thank you, everyone. That was really fun. Thank you, What's AI, for hosting as well today. And if you have any more questions, like ping me on Twitter or LinkedIn or whatever. We'll be posting all of these notebooks everywhere. And yeah, this was really fun. So go ping Buster, go hack it. Take it for your own applications, and yeah, I'll see you maybe at some other presentation.